Today, our show is going to be about asteroids and comets and other interesting heavenly bodies in the solar system, let's put it that way. And we're going to be talking about some sample returns coming from asteroids, if you're aware of the OSIRIS-REx mission. A couple mission scientists, that's over here, who are talking about asteroid sample returns from NASA. But before then, we're going to be talking about comets. And if you saw the recent photos online of all the different comet that everybody was able to photograph, except for me because it was cloudy every time I went outside. I never got it photographed. We're going to be making our own comet on the stream. We have a special guest, one of the educators from the Intrepid Museum, and he's got a little bit of a science experiment where he will be making his own comet and then talking a little bit about the differences between comets and asteroids. Now, the cool thing is this is an experiment. You can, depending on what you have access to, you can do it home. It does require some dry ice, which is frozen carbon dioxide. I'm giving away all these spoilers, right? So it is something you have to be careful with if you are able to get it. But here, I can just go to my grocery store and I can pick up a little bag of dry ice in like a 10-pound bag or something. So it is something you can do at home. If you roll back the video, you want to do it. But you do have to be careful with it because it is dry ice. The trick is the dry ice will actually freeze to your skin. It's so cold. It's literally frozen carbon dioxide, right? So one more time before we get the event started, let's make sure that everything is good. Hey, Jay, how are you doing? Hydra coming through as well. There's the stream title, Exploring Asteroids in Our Solar System, live with NASA scientists, the Intrepid Museum virtual event. Excellent. Max McSween, how are you doing as well? I'm not sure what the horn there was, but that's fine. Make your own comment. There are 4 words I didn't expect to hear today. Well, it's like make your own stuff that's stuck together, sort of like a comet sticks together, but your comet's, I mean, technically, I guess it's going to be in space. It's not going to be in outer space, but if you count the Earth is in space. Anyways, technicalities. It's cool because you get to see how the comet forms together from all sorts of different aggregates and sort of freezes together, and Frantz will explain a little bit about how that causes the tail of the comet to happen. So, if everything's looking and sounding good, you're hearing me just fine. Sam, thank you so much for showing up as well. If you are able to hear and see me just fine, stand by for just a second here. There we go. We might have a quick hiccup, but we should be back. Y'all just confirm for me that we're still good to go. We may have dropped a couple frames there, just a temporary download issue, but I've snuffed it out. It should not be downloading anything anymore. Let's hop over and let's talk with Frantz from the Intrepid Museum. Let me see if I can click on the right button to do that really quickly, like this. Frantz, how's it going, man?
What's up, Das? Good to see you again. It's been a while.
How are things going over in your neck of the woods? We're all still stuck at home. It looks like you're in your home studio as well.
Yeah, I'm still here, but luckily and graciously, we're going to be opening up on September 25th at the Intrepid. So I won't be stuck in my house for too long. We're going to be opening our doors to the ship, so we're really excited for that.
No kidding. It's almost just in time for my birthday there. I appreciate Intrepid Museum opening up for my birthday. That's really cool of y'all.
Did it specifically for you.
Specifically for me. So Frantz, like I was explaining, we're doing the pre-show. Y'all have seen Frantz on the stream before. Educator, hedge educator. That's not even something like that. Educator with the Intrepid Museum. You do experiments and demonstrations like this at the museum on a regular basis, don't you?
Yeah, we do these all the time just to give people a little bit of STEM when they come to the museum, which is science, technology, engineering, and math. Just to put that into the minds of people. It's kind of interesting to see that at a ship.
Yep.
But it's still pretty cool to see.
Good deal. So you do when the museum was open prior to the COVID thing, you would do presentations and stuff at the museum, but you've also been doing virtual presentations since we've been sort of in this mode that we've been operating for a couple months. Are you going to go back to doing presentations at the museum again? Do we keep doing the virtual stuff? What's the plan with that? Do you know?
Yeah, I think almost like a hybrid model, if you want to call it that, right? An idea of, sometimes being at the ship, but then sometimes being able to do it at home. And I think that that's what this lends itself to, is it lends itself to the flexibility of being able to do it on site or off site.
Yeah.
So we're really excited about the dynamics of this. So it's going to be really cool.
Absolutely. Well, I appreciate you getting all set up with the laptop and all the demonstration materials. Tell us a little bit about the pre-show exhibition we're doing here today. I explained a little bit about Comets, but what do you have going on?
Yeah, so today we're going to make a comet, right? And it's important to talk about comets, and we'll talk about that at the end. But a long time ago, comets were seen as these celestial things that just went inside what were in outer space, kind of like the stars, and they had this mysticism to them, right? And people thought that whenever they came was a bad omen or sometimes a good omen, right? And scientists started studying this, and they realized that whenever you start seeing things and it's a pattern, that's something that nature wants to happen or something that nature causes to happen. And they realized that comets stem from a place in our solar system, two places called the Kuiper Belt and the Oort cloud, right? And they're these rocks that basically are floating around still in the gravitational pull of our sun, but they're far away that they don't come careening into it, right? But sometimes they get jostled around, they bump into each other, and some comet comes right in toward the inner parts of our solar system.
Right.
That's what we're going to kind of simulate right now.
Okay, so you've got a demonstration you're going to do for us. So, folks, I'm going to turn it over to Frantz here. Show us some of your materials here, and we'll get started so we can see what you're doing.
So that's the main part. That's the main difference between asteroids and comets is the materials that they're made of, right? We'll talk about asteroids a little bit later, but for comets specifically, we'll talk about what comets are made of right now. So here I have a bunch of stuff, and hopefully you all can see some of the stuff that we have here on the table. Okay, and so this is gonna represent our comet. And we're gonna put our comet inside of this bag. Now, before we do this, safety first, ladies and gentlemen, we're gonna use some gloves because dry ice is extremely cold, right? And so the first thing that we're gonna put into our bag is some soil. And that's what's in here, right? This is gonna soil, and the soil is gonna represent carbon. It's gonna represent rocks, right? So we're gonna put our soil inside of our Ziploc bag, right? And that's because there's a lot of rocks and soil and carbon in our solar system, right? A lot of dirt. So we have that in there. Then we have sand, right? And this sand represents silicate, which is pretty much sand and glass, right? And so we're gonna put this in here as well. Then this blue stuff is not Gatorade. I'm not gonna drink this. This happens to be glass cleaner. And this represents ammonia because in the comets, there's also a lot of methane and ammonia, a lot of different gases that are swimming around inside of our comet there. And so we have all that. Oh, and we need two more ingredients, just two more things. And the first thing we're gonna be very careful with this is our dry ice. Now, I need to put our dry ice into a fine powder so that way this works properly. So I'm going to put my gloves on here. And please do not judge me for my hammer. The only hammer that I have in my house here. But we have this fancy hammer with pink polka dot hammer.
I think it's a fantastic hammer, Franz. As long as it crushes up the dry ice, it's perfect for this demonstration.
Right? It gets the job done, right? So we're going to kind of cover this up slightly. Just beat up on the dry ice. A nice powder. You guys can talk among yourselves at home. All right. This. See what we got here. That's pretty good, actually. So you can see now we have this powder. So what I'm going to do is take some of this here, and we're going to place this inside of the bag, right? Now, as I mentioned before, this is very, very cold. And the reason why it's cold is because the Kuiper Belt and the Oort cloud are so far away from the sun, right? So all of this stuff freezes, right? And it's just a big old ball of ice. And actually, what a lot of people refer to comets as are dirty snowballs because of all the dust and debris, plus all of the ice, right? Another thing it's called is a hairy star, because a long time ago when they looked up, it looked like a star, but it had something kind of trailing from it. And we're going to see that in a second with our last ingredient, right? So we got a good amount of dry ice. I'm just going to take one more big piece for the road. And now, the last ingredient is a little bit of H2O. We're going to pour a little bit of water inside of our bag. just like so. And you can see now, my favorite part of this reaction occurring, right? So you can see we're mixing all of this together. I'm creating a mess inside of my house. So you may want to do this. Make sure that you have plenty of towels, paper towels. All right. You can even see the reaction kind of happening inside of the bag. See the water bubble in there? All right. We're gonna squish this up just a little bit more. Our comet's almost complete. We will take it out. Sorry. So here is our comet. Our dirty snowball. Look at that. You see that? So if you look closely at it, you might notice some smoke coming off of it, right? And the smoke that we see and all the bubbling that we see is a process called sublimation, right? It's a fancy word for basically solid turning into a gas, right? Without turning into a liquid. Carbon dioxide does not need to turn into water like ice does, right? And then heat up the water to turn into a gas. It just turns directly into a gas. So as this goes careening toward the inner parts of the solar system, this comet starts to sublimate and it starts to get this really long tail, right? Now, dirty snowballs aside, comets are very, very interesting to us, right? And why are comets interesting? Well, comets are very interesting because of theories of how our planet came to be from these comets, right? So a long time ago, we had our solar system. It's a cloud, all the dust and debris is just going around, and we're creating planets, right? Our sun is being formed. But then in the outer parts of the solar system, all of the debris and junk starts kind of coming together to form these large, large clumps of ice and debris, right? And this stuff is actually the same exact material that our early solar system started with, right? So when we look at these comets, we can actually look into the past. We can see the materials that our solar system was made with. And also, there's a lot of theories that surround how we came to be connected with comets, right? So there's a series of bombardments of comets a long, long time ago. And scientists believe that those comets brought water to our planet, right? With all this water that's in the comet came to our planet, and this is how we got water, and this is how life started, right? And we know that life needs water in order for it to sustain itself, right? And then another thing that I actually forgot one really important ingredient, and that was this honey. And this is supposed to represent sugars, right? Because there's some sugars and some organic compounds in this as well. So when those comets came to our planet and they crash landed, they could have brought a lot of sugars, which led to amino acids, which are the basic building blocks of life. So we don't know if that's necessarily how life formed, but we know that comets are really, really cool things. And when they come to our planet, they bring a lot of really cool things along with them. So as Das said, ladies and gentlemen, this is something that you can do safely at home with the help of your parents. Or if you're an adult, you can do it at your house if you want to. All you just need is carbon dioxide. You can get this from a grocery store. You can get it from a dry ice distributor. And just some soil, some sand, some ammonia, and basically a place to contain all of this mess, because as you can see, I've made quite the mess here, right? Das, do you think our comet passes the test?
I think it passes the test. I mean, we said that we weren't going to try and throw it into space or anything like that, but that is a pretty legitimate comet right there, Frantz.
And the cool thing about this is, if I left this alone for a long period of time, the dry ice will just sublimate away, and then I'll just be left with some wet dirt, which would kind of leave my house in a mess. Now, I do have a bunch of carbon dioxide, and CO2 and dry ice It's really, really cool to create comets, but it's also just really, really cool just to create some really cool effects. So I'm going to take this bowl of water, and I took the liberty of already breaking up some. It's white, so you can't really see it, but I already broke up some dry ice. We're going to just drop it in this water and see what happens. So you can see, just in time for Halloween, we have like a cauldron in front of us with the carbon dioxide reacting to the water. All right.
That is definitely just in time for Halloween. It's sort of a witch's cauldron effect you have going on there.
And one other thing I forgot to mention about comets are there are two main types of comets, right? We have short period comets and long period comets. And the difference between the two are just pretty much the time it takes to orbit the sun. Long range comets take a little bit, they're over 200 years, right? They're so far away, and these are the ones in the Oort cloud. And then short period comets are anything less than 200 years. Now, a very, very famous and popular comet that a lot of people know is Halley's Comet, right? Halley's Comet comes once every 75 years. And actually, Halley's Comet is pretty much the comet that broke the whole entire comet mystery, right? Halley's Comet comes once every 75 years. The last time it came was 1986. The next time it's supposed to come is July 28th, 2061, right? And because it's such a short period comet, it is the only comet that you can see with the naked eye that you have the opportunity to, or some people have the opportunity to see twice in their lifetime. Because the next one is coming around, and after that is 2021, 70 something, I believe, which is a long, long ways away, right? So this is just a brief demonstration about comets and how we can make comets at home, and what comets can teach us about the beginning parts of our solar system, right? And how our solar system came to be. We do lots of different demonstrations like this, as Das said, at the Intrepid. And as Das mentioned, we are also doing virtual programming. As a matter of fact, in October 1st, we will resume our weekly programming that we do Tuesdays and Thursdays from 3 to 4. We call these virtual Intrepid Ventures, where we take visitors virtually through the ship, and actually with the ship being open, sometimes actually physically at the ship, and we explore different things in STEM, history, different things in science education. So we really encourage everyone to check out some of the things that we have to offer. You can check it out at intrepidmuseum.org.
Good deal. I'm going to hop back in here with you, Frantz, and thank you so much for the demonstration. I'll tell you, I've tried to do that. Like long ago, I did after-school programs before I got into the whole streaming thing, and it's actually quite difficult to get the mix correct to make your comet. Sometimes you put in too much sand, and you're like, oh, and then I make and then you pick it up and it falls apart, right? And sometimes it's too much dry ice, and so there's not anything interesting in it. And so you are clearly skilled at comet creation there.
So I'm glad you said that. Actually, I didn't think it was that good. This wasn't the best comment I could have made. And the reason why, you're perfectly right. The reason why is because I did too much pulverization of that, of the dry ice there. I should have left some chunks so that those could have actually, the dry ice could have kind of congealed around
glommed around it a little bit more or something. Like sometimes you put in too much water because you have to add the water so that it can freeze back together, but if you put too much, it melts the dry ice, and then it just all falls apart, and you have a bag of water and dirt and stuff. But you did a fantastic job there with creating the comet on the first try. Let's talk a little bit about this. We have a little bit of time before our guests from NASA hop on. So we just made a comet. The NASA guests are going to be talking about asteroids. So what's the difference between, let's say, the makeup of a comet and the makeup of an asteroid? Like OSIRIS-REx is not sampling a comet. What do we expect, or what do we know the differences are there?
So asteroids are a little bit different. Asteroids are more whole and more solid. And because they aren't in the nether regions of our solar system, they don't have as much ice. They tend to have lots of rock and metal. And that's what makes them very, very interesting. And a lot of the asteroids come from the asteroid belt, which are pretty much remnants of rocks and things that were stuck in between Mars and Jupiter, in between the gravity of the sun and the tremendous gravity also of Jupiter, ripping rocks apart. And that's where the asteroid belt is. So a lot of people think that comets are pretty much just icy asteroids in a way, just without metal.
Yeah. And so that's one of the things. Like if we saw the recent comet that you could see in the sky, if you had a telescope, knew where to look, and it wasn't cloudy, it had the big tail behind it. And
Mhm.
another thing that you sort of get into the difference between a comet and an asteroid, you typically don't see a big tail coming off of an asteroid because it's more, I'm going to use the term solid. It's not made of so much ice. The sun isn't sort of boiling parts of it off and creating that big, beautiful tail you see on the comets. The asteroids are in the different orbit, and their different makeup makes them appear in the sky a little bit differently. That's almost one of the reasons that we see a comet, and it's almost a little bit more special to us because it appears a little bit differently than an asteroid might. I mean, we don't get a lot of asteroids that you can see coming by the Earth, right?
Yeah, and then there's the um, uh, it's just that comets also the name comet comes from the Latin term coma, which means hair, and that comes from the idea of the tail. And actually, there's kind of two tails that come off of the comet. There's one that leads in one direction that's tailing it,
Yep.
right? And that comes from sublimation. But then you also have like an ionization tail from when it gets close to the sun, from the solar winds. So it's just a spectacle just to see it. And I think that's the difference between another difference between asteroids and comets, right? We see comets and they're these beautiful spectacles in the sky, and they interact with our planet. Actually, a comet passed by us in the past, and it had some really hazardous chemicals in it.
Right.
But because the hail is so sparse, it spreads so far apart. Those were just minimal amount of the particulates falling into our planet. So comets interact with us. We can see them. They're beautiful. So comets are pretty special.
Yeah, gotcha.
Asteroids are pretty special too.
I mean, they're all
Not
pretty
to
special. Let's not. The NASA scientists are watching right now, and they're like, "Well, asteroids are cool too." Geez, this whole thing is about comets. Good deal. So we have, like I said, we have just a couple more minutes here. Frantz, thank you so much again for coming by. Frantz is an educator at the Intrepid Museum there, doing a virtual presentation here with the dry ice. Again, like we said at the very beginning, this is something you can do at home. I don't think we have like a link to instructions to do it or anything, but it does have dry ice in it, so you have to have access to dry ice. And if you do have access to dry ice, you have to handle that very carefully. You don't ever try to hold it in your bare hands. You don't ever put it in your drink or anything like that, regardless of what you've seen on Halloween. There are definitely some safety tips for handling dry ice. So we'll see if we can get a link to a safe instructions on how you can do that. But one of the cool things about the virtual presentations is you don't have to. Franz can do it for you, right?
exactly. And I'm not sure if you guys noticed, but the dry ice actually is starting to kind of die down. So I'm just gonna.
Oh,
It's almost. I like think of it like rekindling a fire, like just adding like more.
put
More
another
wood.
log on the old fire there, huh?
Just put another slab of carbon dry ice. This is a really big piece.
Oh, that's a serious chunk right there, man. There you go.
You got a little extra action going on.
And again, y'all, the dry ice, when we say dry ice, we're actually talking about frozen carbon dioxide, right? Normally, you breathe carbon dioxide. Some large percentage of the Earth's atmosphere is made of carbon dioxide. And normally, whenever it's at normal temperature, like in room temperature, it's a gas. It's something that you can breathe. They actually freeze it down. They go right past liquid all the way down to solid. And that dry ice is literally a solid physical chunk of carbon dioxide. And what it does, like Frantz said, it does what's called sublimate. And all that means, it's a fancy way of saying boiling by skipping the boiling part. It goes straight from being a solid chunk of dry ice to a gas. It goes straight to the vapors that you see. And I think that's why they call it, does that make sense? That's why they call it dry ice, because when it melts, it doesn't leave a puddle. Because it goes straight
Actually,
to gas.
if I were to leave this dry ice just alone in a bowl and just leave the room for maybe a couple of hours, eventually the dry ice will just disappear and there'd just be nothing in the bowl. It's not like melting water, and that's actually why a lot of food distributors would use dry ice to move food across long distances, because the ice, if it melts, it doesn't melt into water; it just melts away as a gas.
That makes perfect sense. All right. Well, I think here, Franz, we're just about ready to start getting our special guest from NASA on here. So thank you
Awesome.
again so much for the comet demonstration there. We'll talk a little bit about asteroids here coming up, y'all. Again, Franz Lucien with the Intrepid Museum, educator over there, a frequent guest here on the Virtual Astronomy Lives. Franz, thank you so much once again.
You so much for having me. It's always great to be able to interact with you and the visitors who watch you. It's always a delight. So thank you so
It
much for
really
having
is. It's fantastic. We can share this with people all over the world while we're still here at home. So
me. Yeah,
hopefully we'll see you at the museum pretty shortly.
definitely.